Good afternoon, Lee McWhorter. Welcome to the second part of the system administration course. Last week, we went through the first part. We covered some of the key terms, the OSI model, cloud virtualization, stuff like that, packet tracer, network components, all the different devices. You'll get plenty of that. And then we covered the operating systems. And then I began talking about shell scripting. And then we were only able to get so far given the time. Bear with me a second. I am going to see what I have available to show on that front. Let's see. Do I have some? I don't think you're just watching me, right? Good. Don't think you're seeing my screen yet. Where is, oh, here it might be. Yeah. Okay, cool. This. Cool. All right, that'll work. One of the things that you have to be aware of, it came up in a question the other day from a student. It is in the material, but by default, when you start working with PowerShell, when it comes to a scripting point of view, by default, PowerShell doesn't allow the execution of scripts. And so one of the things that you need to be aware of is the ability, you have to create, you have a couple options, and I think they're but the best way, in my opinion, is to, that protection, that restriction on running scripts is really there to protect you so that, somebody doesn't slip a script on or, across, and you end up running a PowerShell script that compromises your system. So instead of changing the entire permissions of your system so that you can run scripts across the board, I recommend that you set up a custom shortcut. And so what you have is that you create a shortcut for PowerShell in one form or fashion. And then you basically add a parameter as shown in the material in the lesson to the end of the command line in the target. And I'm going to show you this by, let's see here, let's get back to it. I'll show you how we've set this up. I'm going to share, I guess, just my whole screen. So bear with my cluttered desktop. Where in the heck? Let's share that one. This should be sharing my whole desktop. And you'll see I've created a PowerShell shortcut. Now, there's a couple different ways to go about that, but probably one of the easiest is PowerShell lives underneath the Windows System 32 folder. And you can see that in the material as well. So if you actually just go to your main hard drive, I got all kinds of crap on this box, obviously. Go down to Windows, go down to System 32. Then, if I remember correctly, we should find actually a PowerShell group right down here. Oops, hang on. Well, let me double check my path. System 32, Windows PowerShell. Ah, I see. I forgot the second Windows, sorry. So we'll go down here to look at this screen. Maybe I can read it better. Oh, I see. And I'm in System 32, right? Sorry about this. Yeah. Ah, right there in front of me. And then when you go very down into version 1, you'll actually find the PowerShell executable. And so if I obviously wasn't running that, so anyway, you just navigate down to Windows, System 32, Windows PowerShell version 1, and then you can right-click and drag to create a link on your desktop. Now, I've already done that, so I'm not going to make another one. I'm just going to cancel. But the idea is once you have that link and you open it up, it's going to have this first part here, system root, which is really C:/ or D if you happen to be on a different drive system, and that's C:/ Windows, the system root. So in my case, C:/ Windows, and then System 32, Windows PowerShell version 1, all that stuff we just surfed to. And then you'll see that you got to put a space. This is a key thing, but this is kind of common. Whether it's done here in this target or you could literally type this at the command line. It's one of the things that that's all shortcuts are. They're just basically, you could have literally come down here and type this into here and run that command. Um, and but every command, whether it's on Linux, like you learned in Network Foundations, or even Windows still at the command prompt PowerShell, is usually a model of the command, so PowerShell.exe, space, and then a hyphen and any parameters. And so all we're doing is we're putting this space hyphen execution policy space unrestricted onto the end, so that when we run PowerShell via this desktop shortcut, it will run PowerShell and pass in that unrestricted, and then that one session will be able to run scripts, and we can do our assignments, and we can learn and play, and etc. But if you want to still, then of course, if you just go to PowerShell off the menu and you run it, you'll have your normal PowerShell that would allow you, to do other stuff at the command line without having scripts executable. I ended up actually not on this machine, but on my main desktop that I do my work on in the other room. I actually have a PowerShell icon, and then I have one that says Windows PowerShell for scripting. I changed this, so that it was very clear, and so that way I know if I launch just the regular PowerShell shortcut, it's normal regular PowerShell mode. I can issue commands, I can do things, but I can't run scripts. But if I want to then get into the command mode, I run the one that says for scripting. And so, even though I probably, since this is, I probably just for my own consistency, for scripting. So that's what I would do. Now, if I bring that up, and then PowerShell launches, and we will see that once it takes a moment, it finally comes up and it gives you the PowerShell prompt, and it tells you where you are in the file system. And by default, we're in C:users_lee. For my computer, it'll be your name, or it might be user, or if you're as an admin user, it might be admin, whatever. But that's your folder. The one thing you have to keep in mind is that you have to, in PowerShell, you have to make sure that your script is in the same place that the folder is, that the prompt is, or you have to put in full pathing to try to run. And so what I usually recommend to students is that they just create a folder off their desktop. And so I'm going to call this test scripts. And then now that's off your desktop. Now, if you didn't know this is a Windows trick. Even though when you look with the File Explorer, if you look at the File Explorer, Windows denotes basically kind of, used to, particularly now it has this quick access thing, but it shows the desktop. The desktop is sort of viewed as the top of your system. But of course, the desktop isn't. The top of your system is the root of your C drive, for example. And so when we look at our C drive, we have all this stuff. Well, the reality is your desktop is actually hidden. So I can show you where it is. If I go to this folder, users_lee, then you'll see that's my desktop. It's a fancy little icon, but the reality is it's just a folder. That's why when somebody else logs in, they can have their own desktop. So while the desktop many times is portrayed as the top of your system and everything's there, the reality is it's underneath C user username desktop. And then, of course, once you go in there, you see all the stuff, including my test script that I just created. Now, while that works, oops, trying to get this out of the way and make it go. In this case, how do you get, well, you use actually some of the same commands. While you learned about all kinds of commands like CD and things like that, the reality is many of those, not all, they have differences, but many of the same basic, at least file navigation, CD and things like that, they work the same. So I can do this, CD space, and then I can actually hit just the first few letters. Remember, even though you learned about it in Linux last time, the reality is most major operating systems have command line completion. And you'll see it's changed it to be CD space dot/desktop. Well, dot is a reference to the current directory, so that's a little redundant. I want to change to the desktop in this folder, which you could have just said desktop and it would have worked too, but that's the way PowerShell completes it. You can use dot to reference the one folder up the tree. I'll show you that in a second. And that works on Linux just as well as it works as it does here. And you'll see now it says I'm in the desktop. If I do CD dot, I'm back to just my Lee folder. My space bar is really acting up on this machine. And so what I tell people to do is create their folder off their desktop. You can technically, especially if you're comfortable navigating around at the command line, You can put it anywhere. You can put it off your C, you can put it under documents. You just have to know where to go get it. But then, but if you make it off your desktop, then you open up PowerShell, you say cd space desktop, you say cd space test script. Is that, yeah. And now I'm in that folder. And of course, there's nothing in that folder but a directory, and there's nothing in it here. But if I want to create a script file, then what I need to do is, remember, script files, both Bash and PowerShell, are just text files. So I'm going to create a new text document. I'm going to call it test1, but we have to change the extension because we generally use the PS, if I can type today, the PS extension. So it's going to say, are you sure you want to change that? Yes. Now I have this script. Now, funny enough, on my system, it looks like something else is trying to claim it. And because PS is also a PostScript file. But nonetheless, one of the things is sort of like when you write HTML, you can create an HTML file by doing that, new text document, webpage.html. But if you double click on it, it's going to try to open in your browser, and you want to get into an edit mode. If we double click on this looks like it's going to open in Photoshop or something, which is not what we're after. So how do we do that? Well, since it's just a text file, just bring up Notepad. And once you have Notepad up and running, then you can actually drag this file into here, and you'll see how the title changes, test1. And then I can, theoretically do something ostensibly fairly simple. And the idea being that then what I can do is, what do I call it, test1. So now I can run test1. Oh, son of a gun. See, Distiller thinks it owns this. So when I ran this, it didn't run as a script. It's trying to just ultimately, okay, I see what's going on. That is not what we want. See, that's the problem with, would you stop? Usually, actually, one of the problems, I guess this is because I have Acrobat Distiller, so it thinks it's a PostScript file that it needs to convert to make a PDF. That is not what we wanted. And actually, I think I know why. Yeah, I forgot the one, didn't I? So that's the problem. I messed up the name of the file. So let me close that for a second. That's why it's doing wrong. Let's rename this PS1, not PowerShell. So let's change it again. Now, there we go. Now it's actually owned by PowerShell. That was my bad. Sorry about that, folks. PS1 is the file format for PowerShell, but the same applies. If I double click this, it's going to try to execute a PowerShell script. I want to edit it, so I have to bring up Notepad and then drag that file in here. Of course, I already made that one change. So now let's see what happens. If I run this script, and this time I run it with the PS1 name, hey, it does what the script's supposed to do. It issued the command for me. And in its simplest form, PowerShell scripting is really that. You might have, let's say you have some task that you have to do every month. At the beginning of the month, you sit down and you sit down at some station, and it could be the PowerShell. If it's Windows, it could be Linux, of course, or Unix system. You're at a command line, and you then all of a sudden start typing commands. So you change over to a directory, you zip up all of the files in that folder, you copy that over to a backup, share, you switch over to another place, you zip up these files, you copy that over to the archive. And so you're just doing this monthly maintenance on your file server, and you do it every month, and you do it through a command line. Or you could, maybe you're doing it in Windows, you could theoretically open up File Explorer, go over there, choose those files, right click, send to compressed file, drag and drop. But if you have to do this, say to 100 or even a dozen folders, and you're zipping up all the files, or you're copying all these and archiving all this off manually, as part of cleaning up, the structure so that, it stays to the most current. Maybe you're taking the older files out, archiving them off. Then the issue you have is that you're going to spend so much time every month issuing those same commands again and again and again. And if that's something you're going to do every month, then this is a perfect task for shell scripting. because as you saw, this script is nothing but a directory of the C, and once I run the script, it does it. Once I put the right extension, PS1 on there, my bad, badly. But nonetheless, what you could see is that, okay, if I have those 20 commands or 100 commands I have to type to do this, I can actually put them into a script, one after the other, exactly like I would have typed them at the command line, and then save them as monthly archive. And then when it's time, now I'll have to take the time to go through it, make sure I typed it all in right, save all, test it, make sure it works. But then from that point on, while I took that extra hour or so to put it together, now every month for the rest of my security or IT life, I'm going to be able to walk in and go run archive. And that's going to run off in the background, zip up all that stuff, copy it all off, and I'm going to go get some coffee. And that is the most simple form is what shell scripting is. But the reason we introduced it, and we talked last week about understanding the syntax and knowing about variables and some of the basic stuff, is because it really starts to gain more power when you really do take that programming approach. These languages support all that. They're simpler, but they still, while we're not going to write a Microsoft Word in PowerShell, that's not the point of PowerShell. We are going to be able to write, now we could write a script that's not all just 100 lines of hard-coded, go to this folder, copy these files, do this, do that. We can actually say, hey, when I run the script, ask some questions. What server do you want me to work on? What machine, what files do you want me to archive? What, date range do you want me to use? And now this script doesn't have to be, and that may be the case, like if I was doing that first version where I just had the lines written, every month I might have to open my script up and go, okay, now I got to change the date to only archive the stuff older than this. And then I save and run it. Well, that'd still be a lot easier than issuing 100 commands, but why even do that? Now I'll write my script, so when I run the script, it says, what archive date? I put in 30 days ago, or I put in April 30th, or whatever. And then as soon as I enter the information, the script uses that throughout the program to go look in all those folders and only archive the files older than the date question. So you can see that even if all you're doing is just putting a bunch of single lines that you could have typed at the bash, the command prompt of Linux or the command prompt here at PowerShell, and you just put line after line into your scripts, then of course you get some value. You can speed things up. But then if you add some basic if-then programming functionality and really take it on in that kind of mentality and take this as, you're learning to program in your first simpler languages. When you get to the Python class later in the course, you'll already have some of this down and you'll kind of understand variables and syntax, and then you can just focus on Python. If all you ever do is just put 10 lines of commands and save it in a script just to make your life easier, then great, you still got something to use out of this. But what you're going to see is that a couple different uses of this, system admins love this kind of stuff because, like if you buy your company you're working for buys a new company, instead of you having to sit down with their 1,000 employee printed out list and then basically go into the, say, user manager and add, right click, new user, fill in the dialog, save, new user, fill in the dialog, save. You can actually set up a script that could issue the commands by reading, say, that in from a comma delimited file or from a spreadsheet or something. You could give it all those usernames and passwords and email addresses and then have the script go off and issue all those commands. And so they can become quite powerful. Just to give you an idea, I want to show you a couple things. I've still got Notepad, so that's cool. These are some that are some additional scripts that I did not write these. I found these out there. These are open source scripts, but just to give you an idea of some things, this one is a little PowerShell script that you can see it was put together, I think, this guy, Rob Van Demond, so I'm giving credit where credit's due. These are just samples. You can find others out there. We do some simple stuff in the lesson, and then point you at some other resources. But you can see that this script obviously is a little more elaborate, and that it's going to basically give us a memory report. Now what I'm going to do is, just to show you, I'll come back to this in a second, but let's take a copy of that. Now I could run this program all the way over here in the possible to show. I just have to type in C:\/ user Lee desktop, the name of that folder, subfolder, etc. But since I'm already sitting here in my test scripts, I'm just going to take a copy of this and put it in that test scripts folder. So it'll be right there. And so if we take a directory in here in PowerShell, then we can see they're both there. And so if I do the memory, and once again, I can use tab completion. So I just had to type M and hit tab and it completes it. So when I run this script, it tells me, are you sure you want to run this script? I'm going to say run the R for run once. And you'll see that it then goes off and does its job, and it comes back with a memory report, and it tells me how much available memory I have. So it has the top line of availability, the total amount. So this machine has 6 gigs of RAM with about half of it free, despite the multitasking going on here. So if we go back and look at that code, I'm not expecting you to fully understand this, but you can see that initially he creates some parameters, the computer basically name, a variable for the computer. And then if the home directory is not equal to the root, then it basically selects a path, and it sets up all these strings and variables. Basically, in this script, you notice that it actually has some comments here, these hashtags or comments in scripts like we show in the lesson. So it says ignore the computer name on Linux and use the proc memory information. On Windows, we're going to use, this is Windows Management Instrumentation. So we're going to use that object to be able to get the information about the computer. So this is, some kind of deep uses of variables that are being defined and strings that are being created in here. And then when you get down at the end, of course, it runs that information, and then you see it writes to the host, physical memory, it pads, and it writes out all the stuff that it retrieved. And so I'm not expecting you to use any of these samples. I mean, you can use them; they're great. There's this just show them, and others out there have made some of these just publicly available. So even if you don't become a shell scripting expert, there are lots of scripts you may run in your environment. They may be created by somebody else, or want things like this that are just standard scripts. And so there's scripts, as you can see, that can do pings or can shut down the host. And so PowerShell is very, very powerful. We can update the Active Directory tree if we have the right rights. We can use all the basic utilities that we might expect we could use, and we can thus combine, like I said, all these commands that we might have to issue on a regular basis into one smart script that'll take care of that for us. The things that I want to point out before I move on, because I wanted to, in this case, since I ran into it, kind of go over this again and have it on video. We'll be switching in future to slightly different workshop-based models, so I'll probably end up doing something like this again in smaller little clips. But there are once you got a couple things to get set up. So you got to make that PowerShell shortcut like we did. You got to go into properties and add that right there on to the end, the space and the execution policy unrestricted. Once you do that, then as you can see, it's easy to run scripts. You can write very small ones like that one, and you can use some of the other samples that are out there. And of course, the lesson takes you through and shows you line by line how to build a basic script, and then you start to replicate some of what you've learned to add some more questions, ask some more information of the user so that script can grow and become more powerful. But yeah, if you can't get this part running, you can't get the script execution running. So I wanted to show that. And then of course, got to remember PS1. I don't know why I had PS, just PowerShell for some reason. I knew that wasn't right when it wanted to open in Adobe. So, and then the trick of also just bringing up Notepad and then dragging in your blank script so that you can, or you can open Notepad and then save as, and make sure you don't, it doesn't have a .text on the end of it. And so once you do that, of course, then you are able, sorry, I'm trying to close things back out. All right. Then, of course, once your environment's set up, it's easy. It's just Notepad and a text, and you can start writing these scripts and run them. You can use the up arrow once you've run the script, and you go back and change and save something, and then you can switch back over, hit the up arrow, and hit enter and do it again. Now, the only thing that I just want to point out real quickly, because some of you may be doing this not in PowerShell, but in the Bash side of things, is that Bash out of the box, of course, you create a script and it'll run if you just follow the example. We'll have that first Bash line that points to it, which is usually the default we show. And then, Bash doesn't have any limitation on running scripts, but the Unix Linux operating system does, because by default, when you usually create a file, it doesn't necessarily have the executable permissions. And so as pointed out in lessons, you're going to have to create on your Linux VM or wherever you're doing this, create a folder for test scripts, switch into that folder, and then you're going to have to use the chmod change mode command to make sure that you give permissions, at least to yourself, to execute that script. That's the only trick on the Linux side. Then once again, you can use Nano or VIM or whatever editor you want to write the bash scripts. So whichever language you want to work with. So that was finishing up a little bit of last week's scripting and showing a little bit of and answering a couple of questions since they've been hit before. And given that took a fair amount of our time, we'll have to kind of blow through some of this other stuff. So let's keep on rocking. In this week's material, we have to cover, but this is admittedly a little high level covering some of these last couple of units here. But we cover vulnerability and pen testing. We cover secure protocols. We cover secure network and system design. We also cover secure deployment, and then the last chapter, just to make sure we're covering these things, implications of embedded systems and the Internet of Things. So, okay, what is pen testing and vulnerability testing? Well, in ways you can think of them as kind of two sides of a similar coin, but the real difference when you get down to it is that vulnerability testing, it is a distinct step, a distinct task. Your job as a vulnerability tester, whether internal or third party, being done, like an audit, external audit for somebody, your job is to conduct vulnerability scans. You're going to scan their network, their systems, their firewall, their servers. You're going to port scan with like Nmap. You're going to do things like that. ARP scan, maybe other types of tools. You're going to learn about these in the coming courses. But nonetheless, you will scan and then you will identify potential vulnerabilities. I found that this machine has a web server, and theoretically I could potentially, try to exploit that. I found that this has an open port. I don't know what's there. I didn't, attack it. I didn't do anything. Vulnerability scanning is to do that. It's that first step, to find vulnerabilities. Obviously, it's a very common step. When you bring up a new system, it should be part of your process in a sense to, somebody probably ought to double check, even though you have technically a policy document somewhere in your organizational plan that at least gives you an outline of how you should set up a new system. If somebody didn't follow it right and they left some services on, then by having some other member of the team, whose regular job is to check out new systems and occasionally just scan the network and scan things, at a vulnerability level, then that way they can compare it against their baseline in a sense and say, okay, well, according to the document, it shouldn't have the FTP server running, but so I guess whoever set this machine up didn't disable that service, and so the vulnerability is there now, and it shouldn't be, and I can point that out, but I'm not going to try to exploit it. My job as a vulnerability tester is to find vulnerabilities, find places, and so what's a pen tester do? Well, a pen tester takes, one way or the other, effectively the output of a vulnerability assessment and attacks and simulates what an outside attacker would really do. And this, of course, could be an internal pen tester. You may work for the organization you're pen testing. And then, of course, you may be a third party brought in. And many, many times in bigger organizations, both of those happen. There are people who do standard scanning and or pen testing inside of their organization, and periodically regulators or auditors are brought in or come in to do the testing from the outside. We obviously want to do our own testing first to make sure we're up to snuff before we have somebody else come in and do this. And so we obviously want to do some of this. And so vulnerability, though, stops at determining vulnerabilities. Penetration testing says, okay, now if it's an internal thing, the vulnerability tester may hand the pen tester the results, and then the pen tester is going to go back and see what they can do. It also depends on what we're doing here, because like I said, that first example of somebody's standard part of their job, new system's online, they scan it, oh, FTP's open, not supposed to be. That's just probably going to be shut down. We're not going to bring in the pen tester we know we don't want that there, so that shouldn't be there. But then, okay, let's say that's not the case. We don't have any extra things. Everybody's followed policy. We've got all the things shut down. We think we're good, but we obviously have vulnerabilities. We run web server, we run email, we have machines up, we have firewalls, we have various things. So now a pen tester can come in and see what he or she can do in that environment. Can they exploit any of those openings? And a pen tester will then go up to the point of attempting to gain, say, escalated access or to gain access to particular data, and then they will then document and report those findings so that those things can be fixed. If there was obviously a way they could get in, then somebody else could figure that way in. And so we will talk much more about pen testing and vulnerability testing actually in the next course, so I'm not going to really beat that one to death today. As long as you get those two big basics, there's some more information, reading the lesson and get through the exercises. But nonetheless, we will spend a lot of time with that in some of the other courses, including the next course, Network Defense. So we're going to talk about secure protocols. Secure protocols is actually a fairly easy thing to talk about. From a security point of view, and a system administration point of view, we obviously have to support protocols. There's web traffic going on our network, there's email, there's all kinds of stuff. But if we can, really, this is as simple as that when it comes to secure protocols. When you can, use them. It's not that hard. If you have a choice, if you can use HTTPS over 80, in many cases, if not all, in most cases, that's probably the way to go. Google's starting to insist on it from searching points of view and emphasis anyway, the whole privacy concerns of the world. But that aside, if you can use secure POP instead of regular POP, then let's use secure POP. Let's use the secure protocols. We have a choice between managing that router remotely via Telnet or SSH. Choose SSH. SSH is encrypted and secure, and Telnet is plain text and open. Now, there's that one other aspect, though, of secure protocols. Sometimes you can't choose a secure protocol because it doesn't exist. In a sense, at the underlying level, IP, TCP, IP, there's no security there at all, if that's all you're working with. And let's say you have some old legacy piece of equipment, or to be, but I mean, in all honesty, the vast majority of even modern equipment still supports basically the old Telnet protocol. Why? Well, it's efficient, it's easy, but yes, it's insecure, but it's also insecure in a way we can work around. So this is another way to secure protocols. So for example, we have a router that we want to manage, or maybe we can only manage a piece of manufacturing equipment that only has basically a Telnet interface to implement. Okay, well, we need to manage that. Well, we're not going to Telnet over the public internet from this office to that manufacturing facility and have that thing directly on the internet, right? No, that's not what we're going to do at all. We're going to set up a VPN between our point and the other point, and maybe even go beyond that. Like I've seen very common, if you want to, you can have what would be referred to as an out of band. It's outside of your general network. I have seen people literally set up modems that, so somebody dials into that modem, and then from there to there, Telnet's in. Okay, as long as that modem access is secure, then no one's going to break into that Telnet. And of course, the same thing with VPN. If you have a solid VPN connection from this office to that office, and then there's a one hop over on the local network through that VPN, then even though you're logging in via Telnet halfway across the world, the entire, the segment, that last hop that is inside your network. It's in the server room. No one can put a packet tracer there and catch it because you've got it locked, right? You've got your security in place, and you would know. On the other hand, anybody along the way is going to see the encrypted VPN traffic tunnel, and they're not going to know. So there are ways to get around the fact that we may have to use an insecure protocol just by wrapping it in an additional secure protocol. So take a look at that. There's a lot of discussion in there of the different protocols, which are secure, which aren't, what levels of the OSI model that they relate to. Some of that's ostensibly a review, a very important review if you ever take the Network Plus test. If you haven't, despite having, you should be at about that level in this program, and if not, but after you're done with this program, you should be. And so, being able to know what protocols operate at what level, what equipment operates at what level. There was a bunch of questions on OSI model in the network test, and some in the security, but mainly the network. But anyway, so we cover all these different protocols. It's important, especially in some of those situations, to know the protocols and their ports as part of both testing and just knowledge. If you're going to work in that area, you're going to want to know these because these are the defaults. So if you work in VoIP, you'll need to know SIP and real-time streaming and some of these other protocols that are used. If you don't, then you may not have to memorize those besides for a test. So, but like I said, in a nutshell, if use secure protocols or mitigate the use of unsecure protocols is all about. And then when we talk about secure network and system design, well, there's a lot of things in there, some best practices. I'm trying to skim to because these aren't super hard in and of themselves topics. I want to make sure I hit the important things. But one of the things that I want to point out is that a couple classes back, we beat to death, and now they've been mentioned already, and they'll be mentioned again and again. These concepts like layer defenses, security in depth, least privilege, diversity, limiting, etc. Well, keep those in mind beyond any best practices that a particular network design best practice guide might tell you, even our lesson or systems design. The idea is that you keep those huge security concepts, and also maybe some things you've learned from some of those frameworks, because there already may be guideline documents on how some of those things are done. So you're not starting from scratch once again. And you can sort of see those. So you want to follow those best practices, keep all those core principles in mind as you do a system design or a network design. So you want to think things through as you go through that process and think about security from the beginning. While we want to have maybe a couple places that if we have a big important network, internet connectivity, maybe we need to have 2 different connections out. Well, that doubles our risk, but that was because we need to have that redundancy for uptime. But that means we need to secure both of those connections. But we don't want to have one, we don't want to pay for it, and we don't need in this day and age, especially with cloud and other things, we don't need to have 16 internet connections at one office. That's too much redundancy, and plus then it would make too much risk. So we've got no really complex, and we're not keeping simplicity in mind. So there's these basic concepts that you can use when you look at something and decide if it makes sense against those kind of litmus tests, in addition to the best practices and common guidelines. And then there are some specific things which admittedly you won't know at this point, but as you learn more of this program, you'll come back to this. For example, one of the things you're going to learn about in detail in the network defense class after system administration is the concept of port mirroring and how we can use that on a switch to configure a way for a device to monitor traffic. So like intrusion detection. Well, once you know that, then you hopefully can't ever unknow it. And then of course, that's something you should take into account and think about as a more tactical as opposed to strategic when it comes to defense design and secure design. But keep in mind, when you design networks, you want to think about both aspects. You know, we have that confidentiality and integrity and availability, and the availability sometimes gets forgotten. So we want to make sure we're providing the availability. We want some redundancy, but we don't want to go crazy with that because we don't want to open up that many risks. We want to make sure we've covered and mitigated our risks, and we want to take into account in our design for like a network. Okay, where are we going to place firewalls? Where are we going to place intrusion detection? And you'll learn more about that to come back to in your future as you go through the rest of the program. But when it comes to system design, what is a system? That's a little grayer, but the principle is still the same. If you're designing a computer system to do a particular task, that's a system. Your system could be as big as a whole data center with thousands of computers. Whatever this system is powering our search engine, our artificial intelligence infrastructure. So that's the data center. Our system is a small web database that's going to back up our little app or our Salesforce. That's a system. When you go to design it, you, once again, best practices and keep all these things in mind. And so, some of the things, they start to make sense, especially when you think about them in that concept. Okay, this is a server I'm building that's a database, it's a system. It's going to power, be the back end for a little web application or an Android application or whatever the case may be. So obviously I'm going to do the basics and the best practice. I'm going to harden this thing, shut everything else off. It doesn't need a web server, or maybe it does. Maybe it has a web server and database and that's all it is. So I turn off everything else and I harden that box. Well, I'm simplifying it. That's a good thing. It's a big principle, but I'm hardening it. That's a best practice. And these things start to come together. And then of course, since I know I have particular things that are going to run, do I use some kind of DAM, database access monitoring, on that machine since it's important? Do I use some kind of host-based intrusion detection because it's important? Do I have an inline some protection? What firewall rules would this need, etc.? So once you start to get the basics of this stuff down, then when you have to apply it in a particular area, then you start to get the idea of how that works. It's like you just keep the main concepts and then you apply them. And of course, we have the various guidelines and documents and frameworks out there that we can use to help us too. So there's a lot of best practices in that one, both for secure system and secure network design. We take you through, I believe, a pretty good example of a simple network architecture and how to build on it from a security point of view. And of course, you could then build on it from there, and we do it in the exercises. So then 9 is what's called secure deployment. Okay, so what is secure deployment? Well, in the broadest sense, there's 2 ways to look at it. you can, and you need to. There's a best practice, and we've mentioned it before, basically patch management, or keeping things updated, keeping your devices updated, keeping your servers updated, keeping your routers updated. So that is patch management. It's important, and we say it's a best practice in security, and generally speaking, it is. You want to keep things as up to date as possible, especially if there's security fixes in those patches, because you want to have those. But you also have to be secure in how you deploy said updates. As I may have mentioned, I forget from one lesson, one class to the next, which examples I use sometimes, but years ago at a place I worked, we dedicated a few machines to be sort of test machines that whenever the automatic patches came out from Windows, Microsoft, and Apple, we wouldn't let that happen to every machine on our network, but these machines would happen. And the very first thing that certain members of the team would do would then run those machines through a battery of test to make sure they still worked on our network, didn't break our internal applications, that connected to our database, crosstalked Mac to PC, and everything was good. And then if it was, we immediately pushed those out, particularly if it was security. We might be a little slower if it was just a feature update or something that wasn't as critical or we didn't benefit as much from. But ultimately, we roll them out and keep everybody up to date. And so that was sort of our secure deployment model. We didn't just automatic update everybody and then half the network break, because we had seen that happen. We instead tested it someplace and then did it. So with secure deployment, we do the same thing. We can test machines today. We can have VMs. We can have a sort of a reference image that is the image. It's a virtual copy of like every desktop in the sales department. And so when it's time, we let it update, or we update it with a patch, make sure it still could do all the roles, and then we can roll that out to sales. Now, this also applies if we internally generate stuff, because when you get down to it, patches are new software updates, firmware updates. They are just software that somebody else wrote, and now we have to securely deploy that within our organization, testing it, making sure it meets that user acceptance testing, and then rolling it out. Potentially rolling it out in stages is another layer of defense, in a sense that if something went wrong and it wasn't noticed during the testing, we don't take the whole company down. We take down one department at a time on that error, and we can fix that. But the same applies if we do our own, and more companies do this. They are building their own applications. They may have dozens. They may have a custom web app that lets salespeople do a proposal on the road. They have information that lets, internal accounts for, and servers that are doing their inter-office communications and project management, on and on. And sometimes they buy this. Once again, then that's just rolling out a patch from somebody else. But many times people have built their own or rolled their own and developed their own software. Maybe that's what you're in the business to do. You sell apps and you have to, then you're the developer and you're going to push that out. Well, once again, you definitely want to check that. You want to make sure that even if it's just an internal app, but definitely if it's going to paying customers or free-to-play game users, you don't want to piss off by breaking everything. So you want to test and test and test and have stages of this. And even when you get into the software development side, you can bring some of this testing from both a security as well as quality control all the way down into the development process, so that automatic tests are happening as soon as members of your team check in code. Automatic unit tests begin to happen to check for known types of things, whether that's a major change in code that just needs to be reviewed by somebody else, or it's something that maybe wasn't properly done in the code that might lead to a buffer overrun kind of error, etc. So that's what lesson 9 is all about: is secure deployment, both from the idea of deploying upgrades and changes, but as well as that when you're in control and you're actually writing the software in question. And so then the last lesson of system admin, which, like I said, the system admin course is meant to give a security professional a broad overview of system administration, because you're going to work with system administrators and your job is going to encompass at least putting in place in some way, shape, or form the guidelines and policies of how to secure all that. So you need to know all this. Well, a big area, and we've mentioned it in the very first class, I'm sure I mentioned it, the challenges of security these days is one of the things driven by this phrase, the Internet of Things. Well, the Internet of Things is basically just a catchphrase for basically putting little computers and internet connectivity into all kinds of crap, particularly consumer stuff. That's the difference. We have actually been doing this for a while, particularly in the industrial manufacturing side of things, with what we would refer to as embedded systems. And actually, you can look at your car probably. Your car, most modern cars today basically have multiple computers. These are embedded systems. There's one that handles the carburetor and the injection system and handles all that. There's ones that handle, sensing the pressure in your tires so they can light up a little indicator when your tires are low, or help you adjust in real time your so there's all kinds of embedded systems within any modern major kind of device these days. And then we also see a lot of times if you take a factory tour at some place and watch how things are made, or you watch that show how things are made, if you really pay attention, sometimes along the way you'll see these little devices off on the side, to the side of equipment, and you can tell even they've been bolted on, they've been added, they're not default. But what they are embedded systems that their purpose in life is to either to monitor or drive that equipment. And there's even a standard SCADA that is talked about in the lesson that is very commonly used and has been used many, many times now to be an attack target. The Americans and Israelis, at least ostensibly, I've heard some people say that that's been claimed. I have never seen the claim of it myself, but that's what most people believe. Attack the Iranian centrifuges, which is funny that story is becoming more important, an example from our lesson, because of the recent pull out of that agreement just the other day, I guess just yesterday. But nonetheless, we or some entities were able to infect their centrifuges through this SCADA embedded systems, and basically slowly but surely drive them faster and faster and faster all the time, telling the control room, oh, everything's okay, it's all good. And of course, then they broke them and damaged them. And apparently, now this has definitely not been confirmed as to who did it yet, but it's a story that I may have mentioned because it's one I've just read recently and happened at the end of last summer, and is only now kind of really starting to bubble up as some of the researchers and some disclosure is happening. But apparently, at least the allegations are, the Iranians learned from that, and they damn near blew up a refinery attacking using the same kind of exploit these embedded systems. And so we're going to see physical world damage start to happen more and more, whether it's somebody blows up a chemical plant someday or something like that by attacking these systems, or what I'm even in some ways potentially more afraid of is that when you get down to it, all the Internet of Things is embedded systems, but now in consumer devices. And the plans call for everything damn near to have a chip and be on the Internet in the coming future. We already have things like Nest thermostats and baby cams and Samsung refrigerators with Android tablets in the front door to keep track of what's in there and how old your milk is. And just everybody. I took a class myself not too long ago through the CompTIA Train the Trainer, and that one of the gentlemen showed a picture of he and his wife. He was the teacher of the class, but he said, this just shows you a current example of how far this is going. And he shows this picture of they had ordered a new water faucet because their faucet on their kitchen sink had broke. So they just ordered a new one. The guy comes in and he sees that there's like underneath, there's this little box with, that looks like a network jack. It was, because this is a smart faucet and it has an embedded system, and you can plug it into your network or jump in on Wi-Fi, and it can keep track of your water usage and all that. Oh my gosh. Well, okay, but once again, all these things are starting to happen, and we're seeing attacks happen because of them. There was the casino in the Southeast Asia that lost their entire list of their main big whales, as they're called. They're big high rollers who spend lots of money and get private suites and all that. Their list was stolen from them by hackers, criminals, and broke into the network of the casino by attacking a smart meter in the fish tank in their entry. And I'm not kidding you, that is real. So they were able to attack this embedded system that monitors the salinity and everything of the water of their fancy fish tank. But since it was on their network, so it could tell somebody there in housekeeping, hey, go add salt, or go add, whatever, go adjust it. It's too hot, it's too cold. Go feed the fish, whatever you're supposed to do. They use that system to then break into a file server, grab that list, and basically send it out, because they're embedded systems. There's talk that every dog's color will have a tracking chip and will be on the internet. I mean, the implications are amazing, what this will do to us from a system admin, from a management, as well as think about it from a security point of view. We are going to have to secure all this stuff. And how do we keep track of this stuff? I mean, we're going to have to start, we should always do site surveys, walk around, get on them out. That's one of those common best practices, I think, from the beginning of this lesson in system administration. And one of the first lessons, go out, don't just expect problems will come to you, go look for them. And that's a good practice. In this case, we need to roam around probably in our team all the time. What if the microwave in a break room gets replaced with a smart microwave? And then somebody realizes this is like the one they have at home, so they plug it into our network. And we don't know about it. Now we have an unsecured device that is got internet access. And that will tell that person who has the one at home and they set it up, they know what they're doing. Their app will say when their microwaving is done or when it's not being used. That's great. But that's connected through the internet, and there's ports open, by potentially. So anyway, these are things we have to be aware of. So that is the last lesson from system administration. The most difficult thing probably of all this is just that shell scripting for, if that's the case, then let me know. If you have problems for whatever reason, maybe with PowerShell, then try Bash or go the other way. Maybe one of them will resonate with you better. They're very similar though, I admit. But like I said, remember the beginning at the latest level, it's just a series of lines and you're automating that. And you can get more complex, of course, and ultimately you will have to get a little more complex, taking some input and using a few variables. But they can get much more complex, but that's where their power lies. And you will see that many times in both system administration, which is why we presented it here, but it's also part of security for that reason too, is because we will use these tools to be able to automate tasks that, at least if nothing else, speed up our job. And in many cases, custom, scans and other things are also done through that, because since you can script anything, you don't just have to use basic Windows or Bash commands, you can call other programs inside of your scripts. So you can imagine if you get the basics of scripting and kind of understand, okay, any command I can type with the prompt, I can automate. Oh, well, if I do, whenever I start a vulnerability scan, I run an nmap this and I do this, and I'm not trying to confuse you, that's coming in these next couple classes. But I'm going to run these tools. Well, I can sit down every time I want to do one and type those commands, or I can build me a script and say, okay, go do all this against that machine. You see what I mean? So that's where the power comes from. So most of the rest of this stuff should be pretty straightforward. You should be able to get through it. If you have any questions, let myself or Joy know. Otherwise, hopefully get through it and knock it out the rest of this week. And then next week, we'll see some of you in network defense as a new course. That's it for this one. Talk to you next week. Thanks. Bye.